In this video, we'll be looking at Chapter 19, Section B on interval notation. Now, we've already seen interval notation in Chapter 1, but it's good to review a few of the concepts. So let's take a look at a number line. From this number line, we can see that we're talking about all numbers x, such that x is between positive 1 and 4, including 1 and 4. And to be extra thorough, we can write that x is a member of the real number set. Remember that this portion of interval notation means the set of all numbers x such that, and then we have our interval, and here x is between 1 and 4, including 1 and 4, and this signifies which numbers we're dealing with, and in this case we're dealing with all real numbers. Remember that in most cases we're going to assume that we're dealing with real numbers, so we don't necessarily need to write this portion. And again, this is an example of interval notation. Let's take a look at a few more examples of interval notation. Again, we have a number line, but in this case we have an open circle above -2 and a closed circle above 1. Remember that the open circle means that we're dealing with that -2 will not be included. So if we start writing this as a number set, we can have -2 is less than x. Notice there's no equal sign here because -2 is not included. -2 is less than x, which is less than or equal to 1. And we include the equal to sign here because we have a closed circle. Again, we're assuming that we're dealing with real numbers, so this is the number line written in interval notation. Let's take a look at one more example. In this case, we have two arrows that are heading in opposite directions, and really we're talking about two intervals here. So we're talking about all numbers x such that x could be less than or equal to 0 because we have a closed circle, or x could be greater than 4, and we're not going to include the equal sign there because we have an open circle, and that's our interval notation. Now I'm going to introduce a new way to write interval notation, and it's called square bracket notation. And really this is a shorthand method for writing interval notation. We get the same exact number sets or intervals, we're just writing it in a shorter way. So for example, if we have the interval notation here where we're dealing with all real numbers x such that x is between 2 and 5, including both 2 and 5, we could write that in square bracket notation like so. X is a member of the interval between 2 and 5, including 5. Now some important things to note here are that we're using square brackets. In this case, both square brackets are pointing in towards the numbers. This means that the number that's closest to that bracket is included. Right? So we have less than or equals to here and less than or equals to here. Because we have those equal signs, the brackets are pointing in. To contrast that, if I gave you the example all real numbers x such that 2 is less than x is less than 5, we would write that in square bracket notation like so. X is a member of the interval between 2 and 5, not including 2 and 5. Notice that the square brackets are now pointing out, away from the numbers, and that's because we do not have an equals to sign here, or an equal portion as part of our interval. So when we're including the number, we point the brackets in. When we're not including the numbers, we're pointing the brackets out. And again, this is a shorthand method for writing out intervals. few more things to consider. Let's say we're dealing with the interval x is greater than or equal to 3. And we want to write that using square bracket notation. We can do that like so. X is a member of, close parentheses here, 3 comma infinity. Because this is an infinite set, there are infinite numbers greater than 3. Now we always use an open bracket or bracket pointing away for infinity, because we can never get there. We can never actually truly include infinity, so we use an open bracket. What if we have an OR statement? Well, for example, we could write x, all real numbers x, such that sorry, let me back that up a second. All real numbers x such that x is less than -3 or x is greater than 2. In this case, using square bracket notation, we could write it as x is a member of, and here we're going to use an open bracket or bracket pointing away for -infinity, comma, -3, another open bracket because -3 isn't included. And here we're going to use the union symbol, which we remember from chapter 1, is just another way to say an OR statement. And then again, we can use an open bracket because 2 is not included. 2 comma positive infinity open bracket. So that might not be simpler than writing in just normal set notation, but you should be familiar with the symbols in the notation here in case you ever see it later on. Okay, let's take a look at an example. Say we're given this number line and we want to write in interval notation both in the normal way and using square bracket notation. Keep in mind that we really have 2 separate intervals here. The first is an AND statement, so we can write that. We're going to assume that x is a member of the real numbers. So all real numbers x such that -3 is less than or equal to x because of the closed circle here, which is less than 4, less than only because of the open circle, or, and now here comes the other interval, x is greater than 8. And again, we're using greater than because of the open circle. So that's the standard interval notation. We can also write that using square bracket notation in the following way. X is a member of, and we have closed bracket, -3, open bracket 4, because 4 is not included, union of, open bracket 8, comma, infinity, open bracket. Again, because neither 8 nor infinity are included. And that's square bracket notation. Okay, let's combine what we've been learning in this video with what we saw in section A of chapter 19 on sign diagrams. Let's say you're given a sign diagram and you want to find all the values which make the function greater than 0. Well, we know that there are 2 cases where the function is greater than 0. That's where the positive signs are. And we see that the first interval is between 1 and 3. So I can write all real numbers x such that 1 is less than x is less than 3. Or I can say all real numbers x such that x is greater than 6. Notice I did not use any less than or greater than or equal to signs here. That's because in the initial problem, we're talking about where the function is greater than 0, not greater than or equal to. Since there's no greater than or equal to here, I should have no equal to signs in the number sets. If I had included that equal sign at the beginning, that would change things a little bit. Now I would have x such that 1 is less than or equal to x, is less than 3 or x is greater than or equal to 6. Now I put the less than or equal to sign here because this hash mark is solid, which represents that the function is defined at that value of x. Likewise here. Remember that the dashed line means that the function is undefined at that value of x. So since the function is undefined here, x cannot equal 3. The function is undefined at 3. So I leave that as just a less than sign. We could also write this in square bracket notation, and I challenge you to do that now.